can be written as, for example, transpose of matrix row-wise, first row 1, 2, 3, second row 4, 5, 6 is matrix row-wise, first row 1, 4, second row 2, 5, third row 3, 6. Properties of transpose of a matrix. Here are some properties of the transpose of a matrix. First, transpose of matrix A is equal to matrix A. Second, transpose of matrix A plus minus B is equal to transpose of matrix A plus minus transpose of matrix B if A and B are m by n. Third, transpose of S into matrix A is equal to S into transpose of matrix A if S is a scalar. Fourth, transpose of matrix AB is equal to transpose of matrix B into transpose of matrix A if A is m by n and B is n by p. Examples of transpose. If A is given, then verify that transpose of matrix A into matrix A is identity matrix. A is given. Therefore, its transpose A dash is matrix row-wise, first row cos alpha minus sin alpha, second row sin alpha cos alpha. Multiplying A transpose and A and solving, we get A transpose A is equal to identity matrix, hence verified. Assessment. Before proceeding, symmetric and skew symmetric matrix. There are two important classes of matrices that can be defined concisely in terms of the transpose operation. Symmetric matrix. A real matrix A is called symmetric if transpose of matrix A is equal to matrix A. A is a general 2 by 2 symmetric matrix. Skew symmetric matrix. A real matrix A is called skew symmetric if transpose of matrix A is equal to minus matrix A. Here, A is a general 2 by 2 skew symmetric matrix. Theorems. For any square matrix A with real number entries, A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. Any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Examples. Show that the given matrix A is a skew symmetric matrix. We have given A, so A transpose is matrix row-wise, first row 0, minus 1, 1, second row 1, 0, minus 1, third row minus 1, 1, 0. We can see that this is equal to minus A. Therefore, A dash is equal to minus A. Hence, A is a skew symmetric matrix. Assessment. Elementary operations on matrix. Elementary operations for matrices play a crucial role in